Okay. All right, so this one's going to be exponents number 5. There are only 5 lessons in the exponents unit, so this is the last one. We're going to wrap up exponents this time, and we'll roll in for the rest of this week. We'll start another unit, actually, and I think there's fewer lessons in that one, but we'll take a look at that next. This one's called Powers and Radicals. And it's hard for me to see my board. What's this one say here, Barry? What's that? Is it? Thank you. Is it a 1? Is this a 1 and not a 2?
Yeah.
Here, make it. Sorry, guys. Yeah, I think that's a 1 and that's a 2. Okay, so first things first. Let's start with some basics. Let's do the square root of x. Okay, first of all, this symbol here, technically speaking, the way I learned it, there's 1, 2, 3, 4 actual lines in there, and sometimes I'll see a 5th one in there. I'll see a little thing like that. So the square root symbol, right, has a very specific setup to it. Now, us math teachers, we'll start to get real quick and we'll do things like that, right? We'll start to get kind of lazy and do the symbol lazy. But technically speaking, the radical's got sort of different pieces to it. Okay, let's talk about other things. Since this is a square root symbol, there's a power outside of the symbol here, a 2. In other words, square comes from the power 2, right? So it's a power 2 outside the symbol. We don't show it, it's by default. We get, as math people, we like to just streamline everything and not show it. So there's an invisible 2 on a square root symbol. There's also, back to the 3 invisible 1s, there's an invisible 1 in here on the x. So interestingly, in terms of radicals, there's this thing called fractional powers. This can be written as x to the 1/2 power. Where's the fraction? The fraction is sitting in the power position. So our worst nightmare, right? Not only are we dealing with fractions, but they're in the power position of something too, right? So kind of interesting. But what is happening here? The 1 on the x under the square root is coming up here into the numerator position. Remember that numerator is the top position in the fraction, denominator is the bottom. The 2 is going into this position here. All right, so let's look at another example. Let's move up from a square root. Let's make this squared, and let's make it a cubed root. Now, if it's a cubed root, you need to show the power there. Square root is assumed, you won't need to show it. You can just draw a square root symbol, and that will be taken as a power 2, and it's invisible, we don't write it. But anything other than that, 3, 4, 5, 6 up to infinity, becomes written because you got to tell somebody what that root is. This is a cubed root, or a 3 root, of an x to the power 2. What's the fractional power on this? Can you do it? Can you convert it to a fractional power? Look at the example prior.
2/3.
X to the 2/3 power. Very good. Whoops. And then I proceed to write it wrong. 2/3 power. Right? So x to the 2/3 power. Follow the pattern. The 1 was on the x, so it went up to the numerator position. The 2 is on the x, it's in the numerator position. The 3 goes into the denominator position. This is x to the 2/3 power. Why is the lesson called Powers and Radicals? Because the fractional power produces a radical, and radical is another name for the square root or the symbol, or the root symbol. All right, so, okay, let's keep going. Let's see, do they give us another example? So, x to the 2/3 is a fractional power. Let's do one more. Let's do x to the 5th power. And it's the 6th root of x to the 5th power. What do you get?
5/6.
X to the 5/6 power. Is this okay? Maybe say it. Say x to the 5/6 power.
X to the 5/6 power.
Over here, this side. X to the 5/6 power. Good. Good, good, good. Just practice saying it. It's a little strange. You're saying a fraction in a power position of a variable, right? It's probably new for most of you. Okay, let's go back to a simpler situation, and let's go back to square roots. What is a square root? Let's go back now we did sort of the expanded version of where we're headed. Now let's go back and do some review. And sometimes you would do this in a slightly different manner, but you'll see why it's going in this direction. First of all, what value of root is this when nothing's shown? What root is this if nothing's shown here in the root position? So come back over here.
So it would be squared again?
It's going to be a 2. Okay, so it's a squared. So this by nature, by default, is a square root. Okay, another name for square root is radical. You can call this a radical symbol, a radical 9, or a square root 9. Those are both synonymous. You can say it either way. Okay, are you thinking about what the square root of 9 is? Because this symbol tells you to do something with the 9 under the symbol. What is it asking you to find? What is square root of 9? 3. Okay, and so the definition of a radical symbol or a square root symbol is what number times itself that many times produces the thing under the symbol, right? And you have to say that many times because if it was a cube out there, like if it was the cubed root of 8, you would want to know what number times itself 3 times produce that 8 under the symbol, right? So it gets a lot more complicated kind of quickly. But at the moment, this is a 3. That's what that does. The symbol disappears, it gets executed. So let's go back and kind of run it through the fractional power model, just to see that everything you've been doing already is actually in this format. You just didn't know you were doing it. Okay, so let's write this way. Here's the 9. What's the power on the 9 that we don't show?
1.
Invisible 1. All right, it's there all the time. We don't show it. Why bother showing it, right? It'd be a waste of time. But it is there. It's an invisible 1. What's the power on the square root symbol that we don't show? 2. Okay, so let's go this route and say, what is this in a fractional power?
9 and 1/2.
Everybody say 9 to the 1/2 power.
9 to the 1/2 power.
Okay, so that's what it is. It's 9 to the 1/2 power. And then by way of the idea that square root of 9 is 3, we now get to say 9 to the 1/2 power equals 3. Following all this? Following the logic? So we kind of went down the road of let's expand this to a fractional power. Now let's explain it in a context you've been using all along. You've really been doing, when you took the square root of 9, you've been taking 9 to the 1/2 power. Fair enough? Okay, so it's been with you all along. There was just no need for it before because it wasn't useful yet. Okay, let's talk about sort of 2 related topics, but a little bit off this topic. Let's switch to even powers. All right, so say we have a negative number. Let's take -3. And you square it. So we raise it to the power 2. What is raising to the power 2? It means take the base, the entire base in this example, including the negative, and multiplying it by itself that many times. -3 times -3. What is a negative times a negative?
It's positive 9.
Positive 9. Okay? So what's happening here? What are we getting at with this example? If I give you a -3 and I say raise it to the power 4, do you see the idea that the power is even? The power is even.
Also, if it's even, it's positive.
Everybody repeat. If it's even, it's positive.
If it's even, it's positive.
Right? I mean, and that's the genius of what you're trying to get at. Because what they're going to do at some point is go, here's a -3, now raise it to the power 1,000. Is it positive or negative? Right? And so there's this little idea that if it's a positive value up here, it's going to come out positive, right? If it's an even power, it's going to come out positive. Let me say that right. Okay, let's do an odd power. And you might see where this is headed. Odd power of, so let's do a -x cubed. And the point is, you don't have to do the math 4 times, right? You don't have to say -3 times -3 times -3 times -3 to know that's positive. You can just know that if it's an even power, boom, it's positive. Fair enough? So it's like a quick understanding of a little bit more of powers and how they affect the base. So let's take -x cubed. What is this? This is the base times itself that many times. -x times -x times -x equals. What's a negative times a negative? Positive. What's a positive times a negative? Negative. Negative. And so this becomes x times x times x, -x cubed. All right? The point being, we have a -x, and what do we raise it to? We did a 5, right? I don't have to, and the idea being, let's say this was raised to the power 11 or 21. An odd power will always produce, in this case, negative. Negative. Am I spelling negative right? Negative. All right. So then we have a lot of vocabulary here. Let me scroll over. And you've been saying, I've been trying to use the vocabulary as we're talking about this, but let's run through some examples again. Maybe the biggest idea right now would be this idea of a fractional power. Right? Fractional power, x to the 2/3 power, that's a fraction in the power, it's a fractional power. We understand what a power is, and a lot of times, remember, I will try to use the word power for this position, this superscripted position, but remember, you might have learned exponent. This is an exponent, and this entire thing might be called an exponent also. I'll try to use the word power and base to try to separate in your brain the two. Okay, how about, so we have numerator and denominator. That's just back to remembering the positions in the fraction, numerator, denominator. We also have square root being the symbol, and the idea that that could be called a radical. We also have the idea of superscript. So here's a number in this position, a smaller number up to the right would be called a superscript position. Super being up, and I guess script being written. Then we also use subscript positions where there could be something down here. That's usually a numbering usage, but you'll see sort of different positions all around the idea of powers. Okay, subscript, good, that's a lower value. And then we have some examples. So, quick review. If you had to write the square root of x in a fractional power, what would you write? X. Good. Keep going.
I don't want to say, but it's like 1/2, right?
Yep. So x to the 1/2
Okay.
power. Everybody say x to the 1/2 power.
X to the 1/2 power.
And I think you need to practice it a little bit, right? Because your brain's like, wait a second. This should be pretty much brand new for you. I don't know if you've ever seen it. Now, this is something you've seen before, so don't panic if you start to see a fractional power, especially a 1/2. It just means square root, right? And you can go backwards. So they have us go backwards here. Not really, but let's do a few backwards. If I have x to the 5/6 power, that looks crazy to me. Move it into the square root symbol notation. What would you have?
X, well, 6 would be outside, X, and then 5 would be inside. Would it be like that?
Yep.
Okay.
And you're just planning out. I appreciate I can hear your brain working. Your brain is deliberately going, this one here went on the outside. The denominator went on the outside of the square root symbol. The 5 went on the power symbol under. And you're just sorting out those positions. Literally, just take your brain through it. Like you could kind of hear as the students doing that, right? That's what you want to do at first. Part of it is we learn it mechanically at first. I don't know that my brain ever gets really comfortable with what x to the 5/6 power is, right? That's sort of another step in this whole thing and how we use it. You'll see more of that as you have more situations for it. And so, just a quick review, just to take you back to where you used to be. What is the square root of 25? What's the square root of 25, just to take you back to your prior knowledge?
5.
What do you get? Over on this side, good, you're good. What do you get on this side? What's square root of 25? What number times itself equals 25, right? Good, okay, I got a hand symbol. Perfect, 5. Therefore, if you see this, 25 to the 1/2 power, what do you get? Hold your hand up, give me a symbol. You get 5.
Okay.
Right? And that's sort of where your brain is now making a new shift, a new jump to a new notation and understanding where these things are. They're there all along. And just to review probably really quick, do you remember the 3 invisible ones? If you have an X, where are they? Where are the 3 invisible ones? Okay, here's some of you. Here's one. Here's the other.
Oh, in the bottom right.
They're there all the time. That's why theoretically, I mean, I guess technically not, but I always try to say every number is a fraction because every number or symbol or variable is over 1. So we're always dealing with a numerator position when we're talking about just a regular number or variable. Okay? Okay.